Our next lesson is called the standard deviation of a data set. Statistics contains tools to answer questions that involve variability. We talked about that last lesson. How different are the answers? We want to be able to quantify how much variability exists in a data set, how different the values are from each other. Two statistical measures you've already seen are range and interquartile range. We did that last chapter, and you have talked about it in previous years. So today we're going to look at the standard deviation of a data set. So in exercise 1, it says a marketing company is trying to determine if there is a difference in the age of people who drink two different sodas. They take a random sample, which we again discussed in the previous lesson, of 15 people who like each soda and record their ages. The ages for both sodas are shown below. So you've got soda A and soda B. So you can see the list there of the numbers. I want you to use your calculator to help find the 5-point summary for both samples. So I'm going to pause the video. I want you to pause the video. And I want you to go back and review from yesterday how to enter the lists. And I want you to find the 5-number summary. So that's the min, max, first quartile, third quartile, and median. The only thing we need to talk about before you go do that is that we are looking at two sets of data at the same time. So in soda A, I want you to enter that in list 1. So you've done that before, but when you do the data for B, I don't want you to erase L1. I want you to leave L1 there, and you're going to arrow over to the right, and you're going to put soda B's information in L2. So I'll start it with you so you understand what I mean, and then you can pause the video and do the rest without me. So let's take a look at the graphing calculator. We're going to go to Stat and Edit. And I already have the list from our previous lesson in here. So I'm going to go to the top and I'm going to hit clear and enter, and that'll clear out my entire list. So this is where I'm going to start typing soda A. So for example, 18, enter, and 16, enter, and so forth. So I'll fill all those in, but then I'm going to arrow over to the right and I'm going to enter soda B under L2. So that will be 25, enter, 22, enter. So the trick is going to be when you calculate the 5-number summary, if you remember, you go stat, and then you arrow over to calculate, and you pick 1. You're going to have to do this twice. So do it first where the list is L1, and then you'll go to this L1, clear it, calculate 1, and you will go up, and this will be L2 instead. So second, and then you'll put L2 in there instead of L1. And you can just delete that. Okay, and then you'll calculate it a second time, but it'll use all the data in L2. So at this time, please pause the video, enter your two data lists into L1 and L2, and calculate your 5-point summaries. I would suggest you go back to your notes from yesterday to help you do this. So now that you did that on your own, I hope that you were able to recall from yesterday how to do that. Again, if you're not sure, you can go back to yesterday's lesson and yesterday's video. Here are the answers. For soda A, your min is 16. First quartile, 18, median 25. Your third quartile was 36, and your max was 44. For soda B, you have a min of 18, a max of 30. First quartile, 19, third quartile, 27, and your median was 23. So yesterday we drew a dot plot. I want to show you how you can actually plot the key 5-point summary and actually create a box plot today. So we're going to create both using the same grid, and we're just going to stack them. So I'm going to actually start with soda B, because I want to put that one kind of on the bottom as the second one, and soda A on top. So what you want to do is kind of take and first mark those values from the 5-point summary. So your min was 18, so that's about here. Your max was 30, so that's here. Then you had a first quartile of 19, a third quartile of 27, and your median was 23. So the way you make a box plot is that you are going to make tails on both ends. The ends should be tails. And then the middle 3 data points are connected in a box. And then you draw a vertical line down where the median is. And we're going to label that with soda B. So again, we plot the 5 points, tails at the ends, and then the middle 3 data points create a rectangle with a line, vertical line, cutting through the median. So I can demonstrate again with soda A. The minimum for soda A was 16. The max was 44. Then we had a first quartile of 18, third quartile of 36, and then our median was 25. So again, we're going to put a tail at each end, and then the middle 3 are going to create a box, rectangle, and then vertical at the median. And this is soda A. So that is what a box plot would look like. You need your 5-point summary in order to do that, and then make sure you create it like I just explained. So now I want to look at this information and what it means for us. So first thing I want to know is what's the interquartile range. So remember from previous lesson, our IQR is calculated by doing Q3 minus Q1. So we're going to do that for each soda. Let's do soda A. Q3, so our IQR is equal to Q3, which was 36, minus Q1, which was 18, so that's 18. And then for soda B, our IQR was 27 minus 19, which is 8. So it says, make a statement comparing the ages of people who prefer each soda. Include both a comparison of the medians of the groups and the variability. So I'm going to highlight both of those because that's the information they want. They want a comparison of the medians and the variability within each group. So let's take a closer look here. We're looking at medians of 25 and 23. So they're pretty close together. And we want to talk about the variability. So I see soda A has got an IQR of 18 and soda B has an IQR of 8. So that information is going to be put all in a summary to do this comparison that they're talking about. So let's start with the median. The median age of those who prefer, so let's look. Median is higher for soda A. So we're going to say the median age of those who prefer soda A is 2 years higher than for soda B. So that's me comparing their medians. Now we'll look at the variability. So 18 and 8, 18 is much higher than 8. So soda A has more variability. So there is more variability in ages for soda A. I'm even going to take it a step further here, and I see that if I think about it, soda B is less, it's 8. Even if I doubled 8, I'd get 16. So soda A is more than double. So I'm going to make a statement about that. The IQR is over twice as much as for soda B. So that means there's a greater range of typical values for soda A. So we'll finalize with that. There is a greater range of typical values for soda A. Okay, so let's move on now. That is all information that we did yesterday. The only thing really new here is creating the box plot instead of a dot plot. So we have our sample of data, we have a statistical question, and now we have information about the variability from the IQR and the medians. So now I want to move on. It says interquartile range gives an excellent tool to quantify the variation that exists in a data set. Another tool that statistics has developed is known as the standard deviation of a data set. The formula for calculating standard deviation is pretty difficult, so it's beyond what we need to do in this course in algebra. What we're going to do, though, is use it to make conclusions and interpret our data. So again, the main shift here is we're going to start talking about standard deviation. So in exercise 2, given the two samples we have been working with, use your calculator to find the sample standard deviation for both sets, S subscript X. So that's going to be the notation that we use for standard deviation. And it says round each answer to the nearest tenth. So that's typically what standard deviation is rounded to. So the good news is that that same one variable statistics that you always calculate has the standard deviation in that big list of information. So I'll demonstrate and show you what it was for L1, and then you can do the same, L1, which was soda A, and you can do the same thing for L2, which was soda B. So if I go back to stat, and I go over to calculate, we're going to do one variable stats, and I'm going to do that for L1. When I do that, you can see S with subscript X is listed right in all that information, 9.0921 and so on. They wanted it to the nearest tenth, so that would be 9.1. All right, standard deviation SX equals 9.1. Now you do the same thing for soda B. Pause the video, calculate your stats again if you need to, and record the standard deviation for soda B. Okay, so now that you had a chance to do that on your own, I hope that you got standard deviation of 4.1 there. Now, typically you label these with the units of the question. So these would be ages, right? So this is years and years. So exercise 3 says, how do the values of the standard deviations you found in exercise 2 compared to the values of the interquartile ranges you found in exercise 1C? You can also compare them back to the IQR. So if I go back to the IQR, for soda A it was 18. My standard deviation is 9.1. So that's about half of the IQR. And my soda B IQR is 8. And that's about half of the IQR for soda B. So we are going to write here the standard deviation, or deviations, there's more than one, are about half of the IQR ranges. They are showing the same thing, though. I still see a significant difference between the standard deviations for soda A and for soda B. So they show the same result. And I still conclude that soda A has a larger amount of variability. So underneath that, the meaning of standard deviation. Standard deviation measures the variability within a data set and roughly gives us an average distance that a data point is away from the mean. So exercise 4, according to the answers from exercise 2, which was up here, the standard deviations, in which of the two data sets is there a greater diversity in age? So that's definitely soda A. And that's because it has a larger standard deviation. Okay, so there's more diversity in age. The variability is larger, as we concluded up above. Most data within a data set falls within one standard deviation of the mean. So in exercise 5, it says find the mean for each of the data sets, round to the nearest tenth, then construct an interval of ages for both data sets that represent all values within one standard deviation. So you should be able to go back and look at your 5-point summary, that whole list of data, and get the mean from that. So for example, I'll demonstrate for SOTA A. Remember, we go to stat, over to calculate, one variable stats, and enter. And I can go find my mean by finding the X bar. So I see that it is 26.7 if I do that to the nearest tenth. So we have SOTA A. The mean is 26.7. So we will find one standard deviation in both directions. 26.7 minus 9.1, which would be 17.6. And then 26.7 plus 9.1, which would be 35.8. So we know they're going to be anywhere from 17.6 to 35.8. I'd like you to pause the video and do the same thing for SOTA B. Resume the video when you're ready to check your answers. Okay, so you got to try on your own. The mean should have been 23.4. Your standard deviation for SOTA B is 4.1. So you want to find one standard deviation away in both directions. So you'll subtract 4.1 to get 19.3, and you'll add 4.1 to get 27.5. So it's going to be anywhere from 19.3 to 27.5. So now using that information, we're going to look at exercise 6. The data sets are given again below. For each data set, circle all of the values that lie within one standard deviation of the mean. So remember, one standard deviation. So we're going to circle for SOTA A all values between 17.6 and 35.8. So that would be 18, 22, 28, 18, and 21, 22, 29, 25, and 27. So we'll count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pieces of data that fit that criteria. So then we'll do the same thing for SOTA B, but this time we're going to circle all the ones that are 19.3 to 27.5. So I'll circle 25 and 22, 27, 22, 25, 23, 26, and 20. And here we have 1, 2, 3, 4, 5, 6, 7, 8. So in our final question, exercise 7, they want the percent of each data set that falls within one standard deviation of the mean. And we're going to round this time to the nearest whole percent. So no decimal points here. So for SOTA A, we had 9 out of 15. If we were to divide 9 divided by 15, we would get 0.6. So that is 60% of the data. And then SOTA B, there were 8 out of the 15 pieces of data. When you do that on your calculator, you get 0.5 with just the 3 repeating. So to the nearest whole percent, that would be 53% of the data. So today was really about standard deviation, learning that that's another way to measure variability. And we know most data is going to fall within one standard deviation in either direction of the data. So we can figure out how many pieces of data fall within that amount to give our percentages. And that concludes our lesson on the standard deviation of a data set.